Hello everybody, welcome into another lesson. So today we are going to continue in some coordinate geometry with talking about vectors. So what are vectors exactly? They are a change in one coordinate to another in general that have both a magnitude, which is a size of the vector, as well as a direction. Now, when it comes to vectors, you can think of it as a plane is flying 500 kilometers an hour northeast, or a car is traveling 50 miles per hour east. Those are examples of vectors. Or one that a lot of you are probably familiar with if you've ever been under any type of weather warning, such as a severe thunderstorm warning or a tornado warning. You've probably seen on the news where they pull up Doppler radar, they show the line of storms with a bunch of arrows pointing to where the storms are going. And they may have them pointing northeast, like the storms are moving northeast at 35 miles per hour. Those are examples of vectors because they contain both a direction and a magnitude or a force or a size of 35 miles per hour. So how do you obtain a vector? Well, you have two coordinates here. For example, coordinate A with a coordinate of 2, 1, and coordinate B with a coordinate of 7, 4. To find the vector in general, you're going to take the second x coordinate minus the first x coordinate, and then the second y coordinate minus the first y coordinate. Now this does work in reverse also. So for example, let's say I'm going from A to B. You have a little half arrow above AB. That denotes vector AB. If I'm going to go from A to B, of course I'm going to draw a line with an arrow with the arrow pointing to point B from point A. I'm going to take that second x coordinate of 7 minus the first x coordinate of 2, and then I'll take that second y coordinate of 4 minus the first y coordinate of 1. So the vector itself is going to be 5, 3. It's moving 5 to the east and 3 north. So it's moving northeast then. If it's moving 5 to the east and 3 north, it's moving northeast. Then to obtain the magnitude of the vector, which is often how they get speeds for vehicles or planes or boats, or speeds for storm systems that are moving into your area, you just take the x and y values of your vector, square them, and add them together. It almost looks similar to the distance formula, except for there's only one number for each your x and y. You just take those values of the vector, the x value of the vector squared plus the y value of the vector squared, and that's your answer. So in this case, I would take that x value of 5 to the second power plus that y value of 3 to the second power, take the square root of all that, I end up with a magnitude of the square root of 34. The magnitude is abbreviated by an absolute value symbol, which essentially it is. You'll always get a positive result for the magnitude. Now, let's say hypothetically I wanted to go from B to A. I can go from B to A. Of course, your first letter always denotes where you're starting. Whoops, not an arrow, it's a half arrow for a vector, right? And then the second letter denotes where you're ending. Well, in this case, that means the A becomes my second coordinate, so I would take 2 minus the first coordinate of 7, and then 1 minus the y coordinate of 4, and the vector itself, the value of vector BA would be -5, -3. And of course, let's say I were hypothetically going backwards, right? In that case, what I would want to do, of course, is start at point B, go from B to A and put the tip of the arrow on point A. So I'm going left 5, down 3, so I would be moving southwest at that point, right? If I'm going from B to A. But to find the magnitude, I would put in the same values. You put in the square root of -5 to the second power plus -3 to the second power, you'll still get the positive square root of 34. The magnitude wouldn't change, just my direction would. So we'll do some examples of some vectors here. Alright, so let's see now. What if we have the first point? It'd help if I got to the page, right? We're going to go from 2, 0, which will be point A. That'll be point A, will be 2, 0. Then we're going to go to B, which would be 8, 8. 5, 6, 7, 8. 2, 4, 5, 6, 7, 8. Alright, there it is, right there. So this will be point B, which will have the coordinate 8, 8. So we're going to find a vector from the point A, 2, 0, to point B, which is 8, 8. So now that we've plotted our points in the coordinate plane, we're going from A to B. You draw a line starting from A, the tip of the arrow would end up on point B. That denotes your vector from A to B. Now let's actually find the value of that vector. So to find the value of vector AB, which again is denoted AB with a half arrow above it, you're going to take your second x-coordinate of 8 minus your first x-coordinate of 2, and then you'll take your second y-coordinate of 8 minus your first y-coordinate of 0. So the value of vector AB itself would be 6, 8. So it appears to be moving northeast. It's moving right 6, or moving east 6 units and up north 8 units. So it would be moving northeast. Now we need to find the magnitude of vector AB, which can be done by taking the square root of the square of your x-coordinate plus the square of your y-coordinate of the vectors, which 6 squared is 36 plus 8 squared is 64. That would give you the square root of 100. So the magnitude of vector AB would be 10. So the value of vector AB itself is 6, 8. The magnitude of vector AB would end up being 10 when you do the formula for the magnitude. I got some more examples here. Yeah, vectors are relatively straightforward. Vectors are, for the most part, I would say relatively straightforward. Alright, good. I should just have one part to redraw here. Nothing terrible. Alright, let's say I'm going to go from... Alright, so A has a coordinate of 6, 1. So A has a coordinate of 6, 1. Then B has a coordinate of 4, 3. So here's B with a coordinate of 4, 3. So we're going to go from A to B. Of course, we need to draw the vector line itself, start at point A, go to B, put the tip of the arrow on point B. So there's what the vector looks like in the plane. Now we need to find the value of that vector. So to find vector AB, you're just going to take the second x-coordinate of 4. Since B is your second coordinate, it would be 4 minus your first x-coordinate of 6. And then your second x-coordinate, or second y-coordinate is 3 minus your first y-coordinate of 1. So the value you get for the vector itself, AB, would be -2, +2. So there's your vector, is -2, +2. So it's moving west 2 units and north 2 units. So you could say this is moving northwest if you're trying to apply this to navigation or to meteorology or trajectories or what have you. Now that we found the vector itself, let's find the magnitude of the vector. So to find the magnitude, once again, we are going to take the square root of course, the x-coordinate of your vector to the second power plus the y-coordinate of your vector to the second power, which would give you the square root of -2 squared plus 2 squared, which would give you the square root of 4 plus 4, which we know is the square root of 8. So the magnitude of vector AB would be 2 times the square root of 2. So we found the magnitude of vector AB to be 2 times the square root of 2. Let's see, I think I'll do 2 more for that. Alright, let's see, this time point A is at 4, -2. So here's point A, located at the coordinate 4, -2. Point B is located right at the origin, at 0, 0. So point B rests at the point 0, 0. So the first thing you want to do, since you're going from A to B, of course, draw your vector itself, which would start at point A at the tip, and then the end of the arrow would rest at the point B. So there's your vector from A to B. Now we need to find the value of the vector from A to B. So the vector AB, of course, you're going to take your second x-coordinate of 0, since B is your second coordinate, minus your first x-coordinate of 4. Then you'll take your second y-coordinate of 0, minus your first y-coordinate of -2. So the vector AB, of course, 0 minus 4 is -4. Alright, and then 0 minus -2 is 0 plus 2, which is just 2. So the vector itself from A to B, the value of vector AB is -4, 2. So it's moving west 4 units and north 2 units. So the direction would be northwest. Now we need to find the magnitude of the vector. So to find the magnitude of the vector, you're going to take, of course, the square root of your first coordinate of the vector, the x-coordinate of the vector squared, plus the y-coordinate of the vector squared. Well, let's see, you would end up with the square root of 16 plus 4, which is equal to the square root of 20, which means the magnitude of this vector itself would be 2 times the square root of 5 units. So you got the magnitude of vector AB to be 2 times the square root of 5. Alright, let's do one more example for general vectors, then we're going to move on to scalar multiples of vectors and even vector sums. We'll get into some of that too. Alright. Try not to completely destroy this here, right? My goal is certainly not to destroy my coordinate plane. I am going to need it. All right. Let's see, we're going to go from point A, which is at -1, -1. So there would be point A from -1, -1. Point B is at -4, -7. Point B is located at the point -4, -7. So again, we're going to find the vector from A to B. So start at point A for the tip, and then the end of your arrow will rest on point B. That denotes that you're going from A to B. Alright, so there's what the vector looks like. Now we're going to want to find the vector itself. So find the vector from A to B. Well, B is your second coordinate, so you'll take the second x coordinate of -4 minus your first x coordinate of -1, and then you'll take your second y coordinate of -7 minus your first y coordinate of -1. So the vector itself, -4 minus -1 is -4 plus 1, that'd be -3. And then -7 minus 1, minus -1 rather, is -7 plus 1, that'd be -6. So the value of vector AB would be -3, -6. Alright. Which means then it's moving west 3 and south 6 units. So you could say this vector, this thing is moving southwest, whatever it is. Now we just, of course, need to find the magnitude of vector AB, which will take the square root of -3 squared plus -6 squared, which would of course give you the square root of 9 plus 36, which equals the square root of 45, which gives you a magnitude of vector AB that would end up being 3 times the square root of 5. So the magnitude of this vector is 3 times the square root of 5. Alright, so I think we have a good grasp now on finding vectors in general. Let's move on to scalar multiples of vectors. In other words, we're going to do some multiplication with them. I'm just going to leave the coordinate plane up because it is going to come in handy again. Alright. So, let's see. Now, what if we're just going to do some multiples? If I have any number A times the value of my vector xy, that A is called a scalar multiple. That is a scalar multiple. So to find the value of this of multiplying the vector by the scalar multiple, it's just simply going to be that scalar multiple times your x coordinate, and then the scalar multiple times your y coordinate. That would be the value of the vector now when you use a scalar multiple to multiply it. So scalar multiplication of vectors is also pretty easy. For example here, let's say I have 2 times the vector 3, 5, right? So this 3, 5 is a vector. Well, I just multiply both by 10, the x and y coordinates by 2 rather. That would give me a value of 610 for my new vector if I use the scalar multiple. So that would become 610 for the vector. Alright, so what if I had 3 times the vector for -1? Well, that would end up giving me, of course, 12, -3 for my new vector. So scalar multiples, again, pretty dang easy. Let's do one more just for good measure. Let's say I want to do a third. You can also have scalar multiples that are fractions. So I'm going to do a third of the vector -6, -9. Well, a third of -6, that's going to be -2. A third of -9 would be -3. So the new vector I would get from multiplying this vector by the scalar multiple 1/3 would be -2, -3. Pretty simple, right? One second here. All right, making sure there's nothing pressing in my personal life. Okay. And then last but not least for today, we're going to talk about vector sums. So, what are vector sums? Vector sums are, you can actually add 2 vectors. So, let's say I had the vectors 2, 1 plus 3, 6. Well, you just add each coordinate of the vectors, add the 2 plus 3 for your x's, and then the 1 plus 6 for your y. That's going to give you a vector sum of 5, 7. So you just add up your x coordinates and then your y coordinates, you would get 5, 7. Okay, that's great, but what does that look like? What does that look like? So we're going to actually now add these 2 vectors together. We're going to take the vectors 2, 1 plus 3, 6, and now not only are we going to add them, we're going to illustrate what the heck that actually looks like when you do a vector sum. So let's always, when you're doing these, if you need to illustrate it, start your point A at 0, 0. Start at the origin, right? Because after all, that's where you're starting out, so your point A will be at 0, 0. Now, the first vector in whenever you're doing vector addition, that 2, 1 is from my starting point to the new point. So if I have a vector of 2, 1 from 0, 0, well, that tells me my point B, my next point, would actually be at 2, 1. So point B would be located at 2, 1, right? So let's go ahead, let's draw me a nice vector from A to B. A small little thing, right? But you get the idea. There's my vector. Now, the second vector actually is going to be from point B to a point C. So if I'm going to go from 2, 1, and then so starting from point 2, 1, I go over to the right 3 units, okay? So if I go over to the right 3 units, that would put me at 5 for my x-coordinate, right? And then if I go up 6 units, that would put me at 7 for my y-coordinate. That put me right there. So I'll have a point C, then it would put me at 5, 7 for my coordinates for the third point. And then now I should probably move where I'm writing here. I have point B, which is located at 2, 1, right over here. Now I'm going to draw my vector from B to C, so I start from point B to C. I have another vector from B to C. Now we're going to get an interesting thing here. The idea is by adding these two vectors that I would get the vector of if I went directly from A to C without stopping at B. Now this comes in handy. Let's say someone drives a car 5 miles northeast to a destination. They go 5 miles per hour northeast to a destination, and then they go, let's say another 10 miles per hour north to another destination. Well, the idea is adding those vectors, if I could go straight from the starting point to the second destination, what would the value of that vector be? So we will start at point A from 5, 7. I think it's plain to see your vector would be 5, 7, right? That's going to equal a vector value of 5, 7 if you just add your x and y coordinates together, as we already established. And I'm going to use a different color now to draw from A to C. For that arrow, it almost looks like you get a really small triangle, doesn't it? That's exactly what vector addition looks like. You often get triangles. So I started at my point A, always going to be the origin, the starting point. The first vector is 2, 1 to a point B, so that's my point B is at the coordinate 2, 1. And then the 3, 6 is from point B to point C. That puts me at a C coordinate of 5, 7. Well, I'm going to go from the origin to the point 5, 7 then when I add these two vectors, giving me a real vector of 5, 7 when I add them. I got a few examples of this. We'll actually keep A at 0, 0. I'm going to start there all the time. You can think of it again, your starting point, right? That's where you originated from. So let's start there. All right. Now what if, let's see, so I'm going to add 3, negative 5 plus 4, 5. So I am adding these two vectors of 3, negative 5 and 4, 5. Well, okay, first off, if I started at the origin of 0, 0, that tells me from point A to point B, I need to go over to the right 3 and down 5. So there's point B, which is going to be at 3, negative 5, right? If I'm going from the origin. So, you know what? I'm going to move this 0, 0 over. Sometimes it's a little bit of a game here when it comes to labeling these points, so you can understand. Alright, so I'm going to go from point A to point B here. Draw that vector. Alright, very good. There's the first vector. Now, This 4, 5 vector tells me from a point B to a point C. So if I'm going over 4 to the right 4, but up 5 units, what coordinate is that going to put me at for point C? Well, take your B coordinate of 3, add 4 to your X coordinate, since that's your vector, you would actually end up all the way at 7 for 6, 7. So I'll end up somewhere over in here for my X coordinate would be at 7. But then if I take negative 5 and go up 5 units, that would actually put me at negative 7, 0 for my vector, for where point C is. So point C would be at negative 7, 0. If I take this point B of 3, negative 5 and add the vector of 4, 5, that'll put me at point C of negative 7, 0. So now I'm just going to draw a vector arrow from B to C. So there's my 2 vector arrows. Now, of course, let's find the actual value of these sums. If I add 3 and 4, I'm going to get 7 for the X coordinate of my vector. If I add negative 5 and 5, I'll get 0 for the Y coordinate of my vector. So I get a 7, 0 vector for adding these two together. This 7, 0 vector is saying if I went directly from point A to C, that's what my vector would be. As you see then, that would be my vector, would be 7, 0 from point A to C. I said negative 7, 0. It put me at positive 7, 0. What am I saying? It's in the right place. I just mislabeled it. So that's what vector addition is doing, is taking you directly from point A to point C, and that's how you illustrate it. All right, let's do a couple more here. All right. So point A will always be at 0, 0. Let's see which way this one's going. So point A is at 0, 0 here. Now we're going to add the vectors negative 8, 2 plus, let's do 4, 6. So let's add the two vectors, negative 8, 2 plus 4, 6, okay? So this vector of negative 8, 2 tells me that from point A to point B, I'm going to go left 8 units, which would put me at negative 8 on the x-axis and then up 2 at the y-axis. So I would in fact be at the coordinate for B of negative 8, 2 then, if I followed that vector. So now I can draw myself an arrow from, of course, point A to B. And then that vector of 4, 6 is telling me from point B to point C. To find point C, I need to go to the right 4 and then up 6. So if I go to the right 4, that'll put me at negative 4 for my x coordinate. And if I go up 6, that'll actually put me all the way at 8. 7, 8. That'll put me right here. So then my point C will be at negative 4, 8. And then I'll just draw my vector from B to C. Now, by finding the sum of this vector, that would give me the actual vector if I went directly from point A to point C without going to B. So -8 plus 4, that gives me a vector of -4. 2 plus 6 is 8. So my actual vector would be -4, 8. And then I'll just pick a different color and draw my vector from A to C, which gives me yet another triangle, a vector triangle. Alright, so that's basic addition. We're going to do a couple with scalar multiples. We'll do 2 more that actually involve scalar multiples. So, how do you handle addition of vectors when there's scalar multiples involved? Well, let's demonstrate that here, okay? Let's see. For example, we're going to add vector 1, 4 plus 2 times the vector 3, 1. So you can do scalar multiples with vector addition. Well, first thing you want to do before you do anything is multiply this vector of 3, 1 by your scalar multiple, right? You treat it like you would any other order of operations. That's going to give you a vector of 1, 4 plus then 2 times 3, that is 6, 1 times 2, that is 2. So your real vector is going to be 1, 4 plus 6, 2. So always take care of your scalar multiple first. Now we may move on. So point A here is going to be at 0, 0. That's your starting point. This first vector of 1, 4 tells you to get to point B, you need to go to the right 1, then up 4, which would put me right here. So point B would be at 1, 4. Now I'll go ahead and draw my arrow from point A to point B to denote that vector. Okay, and then this vector of 6, 2, after doing the scalar multiple, tells me to get from point B to point C. I need to go to the right 6 units. So to the right 6 units from... Actually, I need to be up 1. I was off by 1 unit here. I don't know how I miscounted. My bad, folks. So, we'll just shift this slightly. No biggie. There's 1, 4. Okay. Now, from point B to get to point C, I'm going to go to the right 6 units. So 1 plus 6 would put me at an x-coordinate of 7. So that put me at 7, 4 to start. And then if I go up another 2, that's going to actually put me at 7, 6, which would be right here for 7, 6. So that would give me a c-coordinate of 7, 6. So now I'll draw my vector from B to C. And then the idea, of course, again, by finding the sum of these vectors is if I went directly from point A to point C. So 1 plus 6, of course, is 7. 4 plus 2 is 6. So the result would end up being a vector of 7, 6 from A to point C. So let's draw that vector. And you get yet another interesting triangle. Alright, one more problem, then we're done for the day. I know this was sort of a long lesson, but vectors are definitely important. They will come up again in future courses. In fact, they'll kind of come up when we get to the transformation section of geometry, which is the final unit of geometry. But that's for another time. Okay, let's say I have the vectors 7, 2 plus 3 times the vector of negative 1, 0. So I have another addition of vectors with a scalar multiple. Well, as I said, always take care of your scalar multiple first. So this would actually turn into 7, 2 plus, then if you distribute that 3, that turn into 7, 2 plus negative 3, 0 for your other vector. Alright, we'll deal with adding them in a second, but point A, again, is at 0, 0. That's a given. That's your starting point. So what about point B? Well, this first vector 7, 2 tells you get from point A to point B, you have to go over 7 units, which would be right there, and then up 2 units, which would be right there. So there's my point B, which would put me at 7, 2 for the coordinate of that, and now I can go ahead and draw my arrow to denote the vector. Alright, now let's say then the second vector of negative 3, 0, that tells me to get from point B to a point C, I need to go left 3 units and up 0. So that would put me back at 4, 2. So C would have a coordinate of 4, 2. So now I'll go ahead and draw my vector arrow from point B to point C, which will look like that. I know it looks a little bit like a mess, but that's exactly what it looks like. Now by adding these vectors, this is telling me that if I go from point A to point C directly, that's what my vector will be. So 7 plus negative 3 would give me positive 4. 2 plus 0 would give me 0. No, 2 plus 0 give me 2. What the heck am I saying? Oh boy, long day. So my vector from A to C would be 4, 2. So now let's go ahead. Let's draw the vector directly from A to C, and that's what you get. So sometimes you'll have some funny looking triangles. It almost looks like it just looks like a weird triangle, maybe even an obtuse triangle, but that's what graphing the vectors will look like with vector addition and scalar multiples. So that's it for the vectors lesson. The very next lesson we are going to go on to linear equations and their graphs. It'll be a 3-part lesson. The very next lesson itself will be about the general form of equations and then graphing them. So I hope everyone has a good night. Take care.